Everyone, welcome to the first lesson of Applications of CS. Today I'll be teaching you guys how to download Python and code with it. I'll also be teaching you guys how to use the command line to navigate through all your files and how to use Sublime Text Editor to actually type your code. So I've added a link down below for you guys to reference. It contains a lot of helper links so that you can research by yourself, as well as all the links you need to download everything. So first, let's go to the python.org/download link. Here you're going to be able to download Python depending on whatever operating system you're on. So Windows, Linux, Mac, follow that. And you're going to be downloading Python by clicking this button. I already have it downloaded, so I don't really need to have this. But just click this and follow all the instructions. If you need to follow the instructions, go here. Otherwise, just click through the helper. Just keep clicking continue until it's downloaded. Once it's downloaded, I want you guys to go back to your home screen. If you have a Mac, I'm going to be teaching this on a Mac, so if you have Windows or any other computer, you can use whatever equivalent that your operating system has. So for Mac, either use Spotlight Search to look for the terminal. Otherwise, go to wherever your apps are, go to Other, and click Terminal. So my terminal is already open here. And this is what I mean by command line. So this is your command line. Here you see a squiggly line. That means you're in your home directory. And by directory, I mean when you go into Finder and you see all your folders, each of your folders are called directories. So these are all directories. The directory that this squiggly line represents is your home directory, which is, if you see this house next to your username, this is your home directory. So this is the place that contains all your desktop documents, downloads, and all those folders. So in order to test to see if you have Python downloaded, type Python, and you should see this triple arrow and this helper text. And all I want you to do is, if this shows up, then you're good to go. Then click, if you're on a Mac, click Control D. If you're on a Windows, I think it's Command D or Command C. You can look it up or test it yourself. I'm not entirely certain. And that exits this Python interactive mode, which I will explain further down the line. So, so far, everything is good. Now, next, I want you to download the stable version of Sublime. So go to the link I have here and go to Sublime Text 2. And I want you guys to download whatever operating system compatible package that they have, and just download, and once again just go through the all the helper text and click continue until Sublime is downloaded. Once that's downloaded, you can go to your applications folder, or you can go here wherever your applications are listed on a Mac, and if you're on Windows, wherever you saved it, it should be there, and you should be able to search for Sublime Text 2. I have it open here, so I'm ready. So the first thing we're going to do after you have that all downloaded, and you can pause me if you haven't finished downloading it, is to go through the command line functions. So here is a basic table of the things that you're going to need from the very beginning. So you can look through that as I'm going through everything here. Otherwise, just follow along. So here you're in the command line, you're in your terminal. I want you guys to type ls, which stands for list files, and that's just going to list all the files and directories that aren't hidden on your command line. So now you can see that I have, a bunch of folders here. So second, I want you guys to type cd, which stands for change directory, and all that does is allow you to navigate through your different folders. So if I want to go into my documents folder, I can click documents with an S, documents. It will go into my documents folder, and as you can see, the name before my username has changed to documents. So I'm in the documents folder, and if I type ls again, I can check to see if I really am in there by listing all my folders. You can keep doing cd to get deeper and deeper, and as you can see, I have a Felix folder inside my document, so I can go deeper into that. And if I want to go backwards, I can type cd and navigate backwards by putting ... which basically means go to the parent directory, which is the directory that Felix is in, and that returns me to documents. If I want to go all the way back to the very beginning, say I already gone pretty far and I'm in 2 folders, and I want to go back to my home directory, I can just type cd and it'll get me back. Otherwise, I can type cd and do that, which will also take me back. So now that you know some basics, I'm going to ask you to navigate into a folder that you want all the files that we're going to be working with to be stored. So I stored it in a place pretty deep into my my drive. So I have another tab here that's already inside of it. So don't worry about all that's here. I was just doing a little bit of stuff beforehand. But I want you guys to create your own folder. And so I'm going to go into wherever I am. Say I want to stay in Documents. And I want you guys to create a folder called Applications of CS. So to do that, you type mkdir, which stands for Make Directory. And I want you guys to type exactly what I have here, Applications of CS. The file exists. Okay, let me remove that. Actually, let me check what's inside first. So you can fast forward this part. I'm just going to check what's inside here. Okay, so ignore what I have here because I can teach you guys this later. Applications of CS. So now it's gone, and I want to create a new file. So mkdir, make directory, applications of CS. So this is going to be the folder, and you can change directory and move into it so that you can check to see if it's actually created. I always forget the S. And so as you can see, it's created and stored here. So if I write list files, it's nothing going to be in it, and that's fine. We're just going to be storing all the files that we're eventually going to create in here. So the next thing I want you guys to do is go to Sublime Text Editor, which is what you see here. And the first thing you're going to see is, oops, sorry, let me get rid of that. Okay, I want you to create a new tab, or if you already have a new tab open, it's going to look like this, Untitled, and you're not going to have any of this stuff. That's just my own files. And as you can see, you have a plain text label here, and I want you guys to change that to Python. So click on it, change it to Python, and hit Python. And all that does is notify the text editor that you're going to be coding in Python, so it can color code your code and make sure it's saved as a Python file. So the next thing I want you to do is I want you to click Command S or Control S, or you can go to File, Save, and save this file inside of your Applications of CS folder. So this is the normal Finder, and all you guys have to do is save it in your Applications of CS folder. So go into that and save this as Hello World with no spaces. The reason why you don't want to type spaces is that when you go into your command line, things that have spaces need to be specially formatted when you want to change your directory into them, because most things, when you have a space break, means that you're changing to a different command. But if you have a file with a space in it, there's going to be a little bit of difficulty with that. So you can look that up yourself. I'm not going to explain it, but that's basically the reason why you don't add spaces. So the next thing I want you to do is in this hello world.py, this is exactly how it should look on your computer. I want you to type this line, and you don't really need to know what it does yet, but I'm just going to briefly explain it after we run it, just so you know how something works, something with Python works, and I want you to save it. So Command S or File, Save, and as you can see, it should say Save down here. So in your terminal, you should be in the Applications of CS folder. If you aren't, try to change directory and go into it like I've explained before. And if you list your files, it should say hello world.py. Now we're going to run our first Python program. It's really exciting. So I want you guys to type Python 3 because we're in the Python 3 version, and hit hello world.py, which is your file name, and click enter. And as you can see, it printed out hello world on your computer screen. So this is the first program that we've written. Now I want you guys to open a new tab. You can do that by clicking the end, or I think it's Command T on your Mac, but for some reason I don't have that configured yet, but I will do that soon. And I want you guys to change plain text to Python again, and click Command Save, save it again, and save it as practice.py. Okay, so you guys are going to have practice.py, but for the purposes of me teaching you, I have this already set up for myself, so you guys will have all this stuff once you're done typing this. So first thing I want you to do is type print hello world again, and now I'm going to explain what this does. So first of all these you don't have to type anything here. All you have to type is this line of code in your practice.py folder. So like that, this is what yours practice.py folder file should look like. And these things with hashtags in front of it, these are called comments. And what comments are lines inside your code that are just for the developer. So for these never get run. These aren't interpreted by the compiler or anything. It's just to notify me of what I'm writing and to make it easier for people who are reading my code to understand what I'm typing. So here we've printed hello world, and what this does is print is basically a statement, a function inside Python 3. It recently got changed to a function. And what it does is basically exports whatever is inside here and displays it to the console, or as we see here, the console is our terminal. So it displayed hello world in the terminal. So that's what we see here. Now, hello world is inside quotation marks because it is what we call a string. And what a string is basically a sequence of characters that you want to export or display, usually to the user. And user being whoever is compiling your code and actually running your code. So I want to display hello world to the user, so that's the sequence of characters that I want to display. We'll go more in depth into it, so you can look up strings if you want, but that's the basic understanding of what it does. So next, I want to print out a few other built-in types that Python has. So go ahead and on the next line, type print none, and with a capital N. So I think a lowercase n works too. Maybe not. But so type capital N. You should see it change color because it's a built-in type, and I want you to click save again. And we're going to keep running this stuff to make sure you don't have any errors in your syntax. Syntax being unwanted characters that Python can't recognize. So if I typed like a random string here, it's going to run an error, and I'll show you guys that in a second. But first, to make sure your practice.py folder file works, go here and run hello world.py again, and it should say hello world. A quick and easy shortcut to copying the previous line that you wrote in the terminal is to click the up arrow key, and it should go to all the previous lines that you've typed. So I'm currently in webcast1.py, so I'm going to have to move into that, so you can ignore what I'm doing right now. But all you guys should be doing is running Python 3 practice.py. And let me add this line here so that you guys can be caught up. Okay, great. So as you can see, this prints out none, and I'll explain that in a second. Let me just move into the current directory that I'm working in. So ignore this or fast forward through it. So hold on one second. cd. And you can see this is why you don't put spaces, because you have to do this notation where you put a backslash and then you put the space to notify the the terminal that it's not a separate command. Fall 2015 applications CS. Okay, great. Lecture code and lecture 1. And okay, here we go. So I'm in webcast1.py, as you can see here. You should be in practice.py. So you should ignore everything that I did here and stay here. And I'll be running Python 3 webcast1.py while you guys will be running Python 3 practice.py. Okay, so as you see, I have the same thing as you right now, hello world and none. The next thing I want you guys to do, well, first of all, I haven't explained what none is. None is basically a null, or I guess a type that basically says that there's nothing there, there's nothing runnable, and it has no property. So it's basically like an address to something that for the purposes of the user doesn't exist. So you're going to be seeing that as we code later on, and I'll explain that later on, but that's something that's very important that you need to know for now. So the next thing I want you to do is, well, you can print a string that's not hello world by putting in quotation marks. Another thing you can do is put in apostrophe, and that does the same thing as quotation marks. And the reason why you have both is if you're typing a sentence, say, this is Felix's, or this is a great course, and you have quotation marks inside of your sentence, in order to not confuse this container, I guess you could call it, you would put apostrophes instead of quotation marks so that it doesn't break and then wonder what this is in the middle. So that's a tip that you can use. You can run it again to check if it works. Make sure your syntax is correct. If it isn't, just make sure this, and this should all be in practice.py folder or practice.py file. The next thing I want you to do is print some integers, and they're called ints in their primitive type is called an int in Python, and I'll explain primitive types later on when we get more into depth of objects and stuff like that, which are more complicated. For now, all you need to understand is that an int is basically like a number, exactly what integers are in the real world, arithmetic world, except it has limits to how big and small the numbers can get because of the computer's architecture, but that's way down the line that we'll explain later. So you can print 1, you can print 2, you can print big numbers, small numbers, negative numbers. So we'll just print out a few just to test it out. You don't have to do all of them. I just want you guys to know that these are all valid integers. Okay, so you see them all here. Next thing I want you to print is a float, and I'll just quickly run through all of these. A float is basically a decimal, basically a number that has a decimal in front of it or behind it. You can look up the limits to a float, the limits to an integer, and stuff like that. But for the purposes of the class, all you need to know is that would be a float, and you can see it there. For an array is just a list of items. It could be a list of strings, so I can say, hi there, everybody. Okay, I can also have an array of integers, 1, 2, 3, 4, 5, and they are both valid. So if I print them out, that's what happens. The next thing I want you to do is print a Boolean value, and this is kind of weird because it's not as intuitive as the rest if you haven't heard of it before. And a Boolean value is just a true-false statement, a true-false indicator. So a lot of times you're going to be writing if statements that determine whether or not something is true or false, and doing something if something is true, and doing something else if something is false. So I want you guys to understand what those are. So print true and false, and these are the indicators for the computer. If something is true, then it prints out true, and if something's false, it prints out false. The next thing I want you guys to do is basic math operations. I'll go through these really quickly because you guys know it's pretty self-explanatory. 1 plus 1, let's do 1 minus 1, 1 divided by 1, and 1 multiplied by 1. So these are all the very basic math functions, and Python actually interprets this entire thing as like a unit. So it'll evaluate the function first and then give you the result. So as you can see here, I got the proper results. If you're wondering why this has a decimal point behind it, it's because the default operation for division is that it returns a float. If you want it to return an int, you can do this and cast it. It's called casting as an integer, and you can see it changes here. Make sure you're saving your document every single time you want to run it, or else it's not going to compile or understand your changes. But we'll explain casting later. For now, just assume that is how it works. Now, the next thing we're going to do is the two more less understood functions. So let's go with the let's go with this. So if I divide 3 by 2, I'll get 1.5, right? But if I don't want the decimal point after it, I just want it to round down, I will do a floor division. And what that does is cuts off the decimal. So even if it's 1.9, it doesn't round it off, it cuts it down to 1. So that's something we'll go over later, which is, it's very useful, but we'll go over it later. Now, another really useful operation is this percentage sign, and you can do that by Shift 5. And the percentage sign is basically, it's called a mod or modulus, I think, if it's the correct name. And what it does is it gives you the remainder of a division operation. So if I do 5 mod 2, it'll give me 3, and that's very useful. You'll see later on. Sorry, it'll give me 1 because the remainder of 5 divided by 2 is 1 because 2 times 2 is 4. 5 minus 4 is 1, so it'll give me 1. Sorry. The reason why you would use something like this is that later on, if you want to figure out if something is divisible by something else, then you can use a mod, and you can figure out if the result of that mod operation is 0, and that's very helpful. Now I want to explain why so far we've been printing everything, and I want to explain why you don't really want to do that all the time. So prints are helpful for debugging. If you want to see your code displayed so that you can see what's going wrong, or what's going right if you want. But the reason why you don't want to use it is because print values, like I said, are just for exportation and display. So if you want to export a value, or export, I'm using that term very leniently, and display it to the user, it's helpful to the person who's reading the, I guess, console, but not very helpful for the coder because print statements don't actually return any value that's useful to be run in the code. So if you look here and I say print 3 and print 2, we're getting a little bit more complicated here. You can take a second to pause and figure out what you think, based on the information I just told you, what do you think it'll print? So I'll give you like 1 or 2 seconds to think about that. Okay, so if you guys, the right answer is that, well, here you have a print statement, and logically, in order for this print statement to know what to print out, it has to evaluate what's inside of these parentheses, right? And we call these arguments. So when you ever have a function and you have one or more stuff inside the parentheses separated by a comma, these are called arguments. So these are two separate arguments, print3 and print2. So in order to figure out what to print, I have to figure out what print3 and print2 are. And to do that, I go here and I say, okay, well, I don't know what print3 and print2 are because I haven't evaluated yet. So it says, okay, I'll read from left to right. So it says, okay, print3, what is print3? So I know what print3 and print2 are. And print3 will say, okay, well, I'll evaluate, so I'll go into what print3 wants to print out. And it says, okay, well, I want to print out 3. And since 3 is an int, which is one of the smallest units of measurement in Python, called a primitive value, which means you can't get more basic than an integer for that specific type of value. And it says, okay, so I know what a 3 is because it's built into my programming. And I know what so now I know what this function wants to do, and it wants to print 3. So it says, okay, well, first I'll just print the 3. Okay, so it prints 3 to the console. The next thing I wanted to do is, okay, I still don't know what print3 and print2 is. I still haven't finished all the arguments, so it goes from left to right and moves on. So print2 does the exact same thing as print3, and it'll print 2. And then it'll say, okay, now that I know what print3 and print2 are, I can finally evaluate this big print function. And the way print is written in the Python is that this comma denotes, like, it separates these things, these arguments, by space. So if I say print hi there, it'll print hi space there. In this case, because I said that print actually doesn't return anything, it's not useful for a developer, this is actually going to return none, as we saw way up here, none. Because nothing is returned, it's only exported and displayed in the console. So let's save it and let's run it. And as you can see here, exactly what I said, it prints 3, and then it prints 2, and then it prints none and none because print doesn't return anything. So, print is helpful for debugging, like I said, but not very helpful if you want to continue using these values in code. So now you're asking, okay, well, how do I actually use, whatever I evaluate here in code? How do I reuse things that I've done? And the way you do that is through pointers or variables and functions. So I'm going to explain that now. So first I'm going to go into functions, and then I'll go a little bit more into pointers and how that's useful for coders and developers. So I've defined a function here called square. And just to explain exactly what I've written here, def is Python's way of defining a function. So when you write def, it says, okay, well, you're writing a new function. So it says, okay, now what do you want this function to be called? And I want this function to square something, so I'll call it square. You can type anything here, it's just the name of your function. So if I ever wanted to use this function later on, I can reference this name. I'm going to name it square because that's more intuitive, and as a developer, you want everybody to be able to who reads your code in the future to be able to understand everything and all the functions and what they do. So this is going to square a number, and I'm going to input a number here, and I want it to square that number. So the next thing I do is type a colon, and a colon says, okay, now I've defined the function, I've written its name, I've passed in an argument, an arbitrary argument, so this can be anything as well. Sorry, I forgot to explain that. This could be x, this could be n, this could be like, well, really long. All that means is that whatever is passed into this argument in the future, so as you can see here, these are arguments that are passed in to print, that's just that. Then inside the function, you can use whatever has been passed in with the, I guess, placeholder of n. So I'll explain that in a second. So what this colon does is that it denotes, okay, after you define everything in the function, now you want to write the function. So you put colon and hit enter or return. As you can see, it's tabbed over. And in Python, things that are tabbed over means things that are inside whatever was one tab less. So define square, you click enter, and it has a tab. It means that everything in here is inside this function. So I can type, print 3, whatever I want, print whatever, or type anything inside here, and whenever I call this function later on, which I will be doing by just typing this, I can do 5, whatever, I'll explain this line later on, and by calling that, I will be able to run whatever has been written inside this function. So for a very simple square function, how do you interpret a square? So I want you guys to think about that for 2 seconds because it's very simple. and what you think I should return. And return basically means that after this whole thing has compiled, what do I want the function to display, or to what value do I want the function to give me, or what object or value or reference do I want the object to give me, so, or the function to give me. So print doesn't have a return, or it does, it returns none. But for the sake of this, I want to square something. So I'll do n times n, and it'll square. So it'll square whatever value is passed in as n. So in this case, I've passed in 5 as n, so it will return 5 times 5, and it'll return 25. So let's run this, and as you can see, oh wait, I didn't print anything out. And the reason I didn't do that is because, like I said, print statements are what displays items to the console. So if I really want to see what it evaluates to, I will print square. So square 5, and it'll give me 25. Now, you're wondering, okay, well, then what's the point of not using print statements? Well, print statements will give you, will show you what the value is. But if you actually want to use the value, I can actually do this funny thing where I can do square the square of 5. So now what do you think that's going to print out? And give it a second to think about it. All right, now, as you might have guessed, it prints 125, or sorry, 625. I'm squaring the value, not multiplying it by 5. I'm squaring it. So 5 times, or 25 times 25 is 625. Now, you're saying, okay, well, that could get kind of complicated, because if I keep adding square, the square, and square, 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 it's going to get really long. So what if I just want to square the square of 25? Say this is like a weird number. Say it's like 7. Say I want to square some weird number, 17.5, and I don't really know what the square of that is, right? So 25, in this case, I could put 25 here, and it would be all fine and dandy. But I want to print out the square of 17.5, and I don't know what it is, but I don't really care what it is. All I have to do is type, okay, well, let's give an arbitrary value to it. So let's say, 7 square of 17, or let's just name it SQ for simplicity reason. So SQ equals the square of 17.5. And the cool thing about this, and this is called, a variable. SQ is a variable that points to the value of evaluating the square of 17.5. So this doesn't actually, this actually points towards the evaluation of this, so I don't have to worry about what this is. All I have to do is, if I want to print the square of it, I can square SQ, and it'll just replace SQ with the evaluation of this. And if I print it, I get some weird, crazy, cool number like that. So now that I finished that, I want to move on to the square root. So I want you guys to think for a second about how you would figure out the square root of a value. And you guys can do that on your own for the sake of time. Exponent, same thing. How would you calculate an exponent? And how would you do something else that's not math related? And how would you take in a name and just print it out on the console? Okay, so now that we've skipped all through those, hopefully you got them all right. I'll try to add the answers to it on the document if I have time. Otherwise, you can look it up. These should be pretty simple functions. The next thing I want you guys to learn is a for loop. And the for loop is probably one of the most important, built-in code that Python has. So we're going to start with a for loop. And what a for loop does is it has a cool syntax called for, and you have an arbitrary value here. So let's call it I. For I in range, let's, A to B, okay? Do something, okay? So this is, a comment, so it doesn't run. So let's explain the syntax of a for loop. So what we're trying to do here is we're trying to create a multiplication function using only addition and a for loop. So here's the syntax for a for loop. And what it does is, for an arbitrary value I in the range of A to B, so it's almost like English, exactly like English actually. And basically what it does is it starts from A as an integer value and goes all the way to B as an integer value. So say A was 0 and B was 100. So it would say for I in range 0 to 100, let's print I. So what it does is, for every value from 0 to 100, it assigns that value to I. So I, the first time this loop runs, it I is 0. The next time the loop runs, I is 1, and so on and so forth, all the way up into 100. And I think actually the way range works, this is also a built-in function for Python. I think range works is it includes the value of A, but does not include the value of B. So 0 to 100 would be actually 0 to 99. If you want 1 to 100, you type 1 to 101. And if you actually need the values to be 1 to 100. If you just need the range, the number of times the loop to go through to be 100, you can always use 0 to 100. It's a little bit more intuitive that way, and it'll run because 0 to 99, including 0 and 99, is 100 values. So what we want to do is multiply, create a multiplication function, and I want to multiply A and B, right? And so what I want to do is, okay, so what is multiplication really? And this is a test for, I guess, how can you think like a computer? So a computer can only, repeat the functions multiple times, and a very basic kind of, doesn't have the human intuitiveness of just multiplying 2 times 3 and just kind of like knowing what that is, right? It has to actually run something multiple times. So 2 times 3 is, in addition is what? If you think about it, 2, plus 2 plus 2, right? So a computer is, can do something like that, where it just is 2 plus 2 plus 2 and gives you 2 times 3. So say you have A is 2 and B is 3. How would you do 2 times 2 times 2? All you would want to do is for I in range, and here I want you to pause and try to write this function yourself. I'll give you a few seconds to write it. And once you're done, or if you're stuck, I'll continue now. So for I in range 0 to B, so say you have 2 times 3, right? For I in the range of 0 to 3, I want you to add, I guess, A multiple times. So I want to get, the addition of A. So back here, when I assigned a value to, a function here, I can also assign a value to a primitive. So if I want to assign, let's say, arbitrary value result equals 0, oops, this will assign result to the value 0. So what I want to do is eventually I want to return result, and I want result to increment by, A every single time. So I want result to keep adding A to itself every single time. Every single time it goes from 0 to B. So what I would do is result equals result plus A, and that will give me, if I print out, print out mult. And the cool thing about Sublime is it actually, fills in your functions for you. So even if you have a long function, you can just go through the drop-down menu. Let's multiply 2 and 3 together. So cool, 2 times 3 is 6. So a shortcut to doing result is equal to result plus A is, Python has a cool thing where you can just do result plus equals A, and it's the same thing as result equals result plus A. Result plus result plus A, and that'll still give me 6. And you can test this with a bunch of other values to see if it works. Okay, oops. What went wrong? Let's see, multiply 4. Oh, I forgot a parentheses here. So a syntax error, you'll probably get this some point during your code. All you have to do is look through and see. You can reference the line number and see where it is, and see if you're missing a parentheses or a comma or some quotation marks. That's usually the case. So yeah, so this function works. You can also do loops using a while loop, and a while loop is a little bit less intuitive. So I'm going to skip this for now, and I want to go to, I'm actually going to move this ahead, this if statement, because we're going to use it in our while loop. So let's describe what if statements are. So if statement is basically a way for you to test if something is equal to something, and return a Boolean value. So it's kind of like a wrapper tester for a Boolean value. So what it does is if true, do this. So I'm going to write out the structure for a basic if function. Else if. Actually, I think it's in Python. It might be elif. Elif, and you have something else true. Sorry, bear with me. You can fast forward through this part. I'm just setting it up. Something else true. Do this. Else. Do default. Okay, so this is a basic if statement, and what it does is it evaluates. Let's do. Let's pass in actually 2 things. So let's say if A equals B. And the way you test to see if something is equal to each other is to use two equal signs, because one equal sign, as you can see above, is an assignment value. So it assigns something to something else. It assigns the first thing to the second thing. Here we're not assigning anything, we're just testing to see if it's equal to each other. So the way Python did that was say, okay, well, two equal signs means, you're testing if something is equal to something. So in this case, if A is equal to B, do this. So let's say print A, A is equal to B. And this is how you would write a print function if you want to attach different types. So A is probably going to be an integer or float or an object or anything, or whatever it is, and I can add plus and I can concatenate that with a string value. So let's say if A is equal to that. Okay, so now if A, let's say if A is divisible by B, print A is a multiple of B. And else I want to say, let's say print A is not equal to and not a multiple of B. Okay, so and we can return whatever. Actually, I'm going to do something interesting, and I'll say string, let's say results string is equal to nothing, and we'll return the result string, and we'll actually, instead of having a bunch of print statements in here, we'll do result string is equal to this, and we're going to change all of that. So you can quickly fast forward through this, not important, it's just just for the sake of consistency. And I can print if statement. Actually, I'm going to change this to if equals, and let's say 1 and 1. Okay, so I want to print out if 1 is equal to 1 and fail, sorry. Let me think for a second. Okay, that was a very novice move. Actually, let's go back and change it back to the print statements, because I assigned this to a string value here, and then I tried to assign it to a concatenation of strings and integers, which is not very well supported. So let's just ignore what I did there and go back to the beginning, and let's just run if. Still change it to if equals though. Okay, sorry, a little bit of a blip there. Sorry about that. But let's once again test if 1 is equal to 1. Oh gosh, it might be this actually. Bear with me. It's been a long day. Okay, there we go. So 1 is equal to 1. So as you can see, we wrote our first actually semi-useful function. If 1 is equal to 1, do that. Else if 1 is divisible by, is a multiple of, 2 is, oh, oops. You have to actually test this is equal to something. So as you can say, else if A divided by B, or A mod B equal to 0, I forgot to make sure that it actually returned a Boolean value. So this actually has to return a Boolean value. The reason why it still works without this Boolean value is because I think, actually, let me look this up for 1 second. Truthy Python values. Okay, well, you can look it up yourself, but I think it's, I think anything but 0 evaluates to, only 0 evaluates to true, everything else evaluates to false. So A mod B is not 0, so it evaluates to false, and it goes on to the next statement. So you can look up truthy and falsy values, and then I'll give you a little rundown of Boolean, and I'll attach a link down below. But so now that we've done this, it should work. So 2 is a multiple of 1. So you can play around with this, and just to explain the brief structure of how this works is if statements, you can, the first statement starts out with if, and it has to start with if something is equal to something, or you can do, actually you can add more complex stuff at it. So if A and B is equal to, and this doesn't make any sense, but you can do if B equals to A. So what this does, 2 ampersands, is tells you to do this and this. So if true and true, you can do that. So you can look that up. This is ampersands, or you can do or statement, and this is or. So if you want to get more into depth of how if statement actually works and how these more complicated things can help you, you can look that up as well. So I'm just notifying you that we will be using two ampersands and ors. So do your own research into how that works, and we can move on. So the next thing is, actually, let me think. Well, I guess we can go over very, very quickly. So I'm just going to write it in a comment here. So this is a multi-line comment. So if true and true, this returns, true. Okay. If true and false, this returns false. So you can try to think of it as I'm typing these out, and ask yourself why. Give me a second. Fast forward this if you need to. Otherwise, you can, I guess, follow along with kind of what I'm doing, but not really point towards that. Okay, so basically what these do is check to see if there is any what ampersand does is it checks to see if both of these values are true. So you can actually continue going on. I think you can add even more stuff by putting parentheses and do like that. So as long as all the statements in your double ampersand statement is true, it will return true. If there are any false values anywhere, it'll return false, because basically what this is saying is if this is true and this is true, then you can do whatever is inside this if statement. If anything is false in between that, then it returns false and just goes on. For this one, this is an or statement. So if this is true or this is true, you can do it. So this is true or this is true. Yes, this is true. If this is true or this is true, this is true. So yes. So all of these will allow you to complete this if statement. But if they are both false, then you move on to the next statement and you don't evaluate. So you can remember this or do your own little bit of research to figure out what's going on there. The next thing is, okay, so let's move on to, actually I'm going to skip the while loop for the sake of time. You can look up that yourself. We'll be using it later on, so I recommend you doing that, but I'll explain it later on if you need. Also, these are two functions that will that you can look up yourself or figure out how you can do these. But I will skip that for now. Maybe I'll return to that tomorrow or during my next webcast, and you can figure out how this stuff works, because instead of doing only math, you can figure out how do you do things that actually help you in real life. And I'll explain that later. But since we focused a lot on math today, we're going to finish off with this FizzBuzz question. And FizzBuzz is a famous problem that has been used to, I guess, weed out CS majors when they're applying for companies during an interview. So a lot of people ask them this question and see if they can resolve it in whatever language that they're being evaluated for. So I will teach you guys how to get through a very basic solution of FizzBuzz in Python. You can look up, there's a bunch of other solutions. It's a very in-depth and well-documented problem. So you can look that up yourself. But we'll use our if statements to kind of solve this problem really quickly. And so I want you guys to think for a second and try to figure out how to do this problem. So I've put the directions here. And so I want you to pause and try to see if you can do this yourself. It should take you a few minutes, but we'll get started once again when you're ready. So now that you've attempted the problem, I want to go through it really quickly about what is the normal, I guess, progression of thoughts of how you should solve this problem. So the normal progression of thoughts is, and I'm going to go through this really quickly because I assume that you've thought about it yourself. And if you need more explanation, you can look up a lot of documentation online. So I'm going to go through this really quickly. You can slow me down if you need to. So the first order of business is to print every number from 1 to 100. So if I wanted to print every number from 1 to 100, I'm not worried about the rest of the, I guess, what do you call it? The rest of the rules to this problem. I just need to start off with the basis of printing at 1 to 100. So like I said, it's inclusive of the first one, but not the second one. So I'm going to print For I in range 1 to 100, print I. Okay, so that's the default method. All right, so now that I've printed 1 to 100, I'm going to, here, let's run fizzbuzz. So print fizzbuzz. Oops, spelled it wrong. Fizzbuzz. Okay, cool. So it should print everything. Oops. Oh, I apologize. I should have run this before. I'm still in the Java mode. So I told you guys the wrong thing. What I want you guys to do is replace all these ampersands, because Python is written for people to kind of get through the basics. They actually replaced all these ampersands with and. It's been a long time since I've gone through Python, and they replaced all these double pipelines with or to make it more intuitive and similar to English. So you should use and or instead of the double ampersand sign. So I apologize. I will try to correct that with annotations over this video. So as you can see, that works, and as well as this, it prints out 1 to 100. Okay. Actually, I don't want it to return none, so I don't want to return anything, and that's fine. And it will. Oops. Oh. That's weird. Okay. Well, let's ignore it for now. We're gonna print something out later on, so it doesn't really matter. Okay. So once again, really quickly, now that I've print 1 to 100, I have some constraints. So for every multiple of 3, I want to print fizz, and for every multiple of 5, I want to print buzz. So you should know how to do this by now from the examples I've given up before, but let's go through this really quickly. So, okay, exactly like it says in English. So if this is a multiple of 3, so if I is a multiple of 3, so like that. Oops. I want it to print fizz instead. Oops. And if I is a multiple of 5, I want it to print buzz instead. So this is the normal progression of somebody's thoughts when they go through this problem. Now, or let's do elif, because it's else if. It shouldn't matter in that case, and the reason it shouldn't matter, you should think of it yourself. Try to think about why if or elif shouldn't matter in that case, but I'm not going to explain that now. So cool. And the default function, if it's not any of those things, is to print I. So let's look to see if it worked. Oops. Return none. And it looks like it works. So let's go through the beginning. 1, 2, 3. 3 is a multiple of 3. Print fizz. 5 is a multiple of 5. Print buzz, etc., etc., etc. Cool. So now that we have the basics going, the final thing is to, for every multiple of 3 and 5 together, print fizz buzz. So let's try writing that. So every multiple of 3 and 5. So oops, 3 and I divided by 5. Oops, equals 0. Print fizz buzz. Cool. So you're gonna fast forward that if you want to. And we're like, wow, okay, so it works. Woohoo! Are we done? And the answer is, oops. Give me a second. Okay, yeah, perfect. So, as you can see, it didn't work, and you're probably wondering, okay, why? That's so weird. Like all my if statements should be correct, and the reason why it's not correct is because if you think about it and you go through this program, if I is equal to 3, if I is divisible by 3, you print fizz, and I equals to 5, print buzz. Well, when you get to here, if I is a multiple of 3 and a multiple of 5, print fizz buzz, it never gets here, because if it even passes the first constraint, it'll print fizz. And if it ever passes just the second constraint, it'll print buzz. So it never actually gets here because it'll just evaluate this instead and stop there. So once it's finished this, because these are else ifs, it won't evaluate any of these as long as something in the previous block has evaluated correctly. So you're thinking, okay, well, how do I fix something like that? If it never gets here and I still need this constraint, how do I get to fizzbuzz? And the solution, I want you to pause and think about the solution for a second. So pause here. Okay, great. So now that you've thought about it, let's go through the answer. And the answer is, well, this is the most specific constraint out of all 3 of these. So if I put the most specific constraint at the end, then the general constraints overpower this, and this never gets run. So the way Python runs in a top-down format, if I put the if statement, the most specific statement on the top, and the more general statements on the bottom, this is the solution. So look up. So 3 is a multiple of 3, you print fizz. 5 is a multiple of 5, you print buzz. So on, yada, yada, yada. And you get to 15, and it prints fizz buzz. And you get to 30, it should print fizz buzz. And 45, it should print fizz buzz. So as you can see, the way your if statement should be written is the most specific thing should be on the top, and the most general thing should be at the bottom. So this is specific, less specific, and then default. So this is your default thing. If none of these constraints pass, you should print the default. So that is the very basic way of writing FizzBuzz according to all the things that we've gone over so far. So I'm going to upload this file so you can use it. Actually, I want you guys to move on to the next webcast that I'm going to have, which is going to be about GitHub and setting that up. And that's how you're going to be getting all the future files and homeworks and submitting stuff and allowing me to check it to see if you're on track or if you have any problems. So I really want you guys to, if you don't watch any of the other videos, I want you guys to move on to the next webcast, and I promise it'll be shorter. I'll keep it really short, and we're just going to set that up so that in the future, most of my videos are going to be around 10 to 15 minutes long, and we're just going to focus on a few very specific things. This was an introductory video, so there was a lot of stuff going on, so hopefully you kept up. If you have any questions, comment below or message me. I'll be happy to answer your questions, and I'm glad you guys stayed with me all this time. So for your homework, actually, for this session, I want you guys to do something, and I'm going to attach this to the document because you guys don't have GitHub yet. If you do have GitHub, I will, and you go on to watch the next webcast, you can actually pull from GitHub and get this code yourself without having copy and pasting it. If you don't want to do that yet, and you just want to do the homework, I will upload that onto the document. But basically what I want you to do is I want you to write a function that will compute an exponent using only addition. So here's the homework, and what it does is it calculates, oops, I will fix that. What it does is it'll calculate a and the exponent of a to the power of b using only addition. So you're going to be using a lot of loops here. You're going to be using a lot of if statements. Well, not if statements, but you're using a lot of loops and a lot of math. And don't worry about what's inside this for now. But the way you would run something like this is you would go to, I'm going to actually, let's go to solutions. I have the solutions up, but I don't want you guys to see it for now, but I will show you how it's run. Okay, so I already have the exponent from add function written, and this stuff inside is what you call a doc test. And a doc test basically uses the interactive mode of Python to run your function, and this is what it's expected to print out. So I've written 2 doc tests here for you. You can add a little bit more, but the way you would run it, is you would run Python 3 x from add.py. Oops. Homework 1, I'm sorry. Homework 1. I'll write homework 1, the solution, you'll write homework 1. And as you can see, nothing happened. And the reason why nothing happened is because I passed all the doc tests because my solution is correct. But if you want to see it actually passing, you type -v, and it will give you a rundown of, okay, it tried to evaluate this, and it expected this value to print out, and it said, okay, it did print it out. And I expected this value to print out after evaluating this, and I said, okay. If you ever fail to pass a doc test, it will tell you even without you writing v. But since I didn't fail anything, it wrote nothing. So that's it for the first lesson. Please try out that. Please check out the next video that I'll probably upload somewhere up here, and you guys will be able to pull and watch all these websites in the future. I promise the next ones will be shorter, so hope you enjoyed it. So